Okay, I wanted to walk through this condensed final exam that we have for the spring 2021 semester. So the first problem and the second problem, they're really very closely related. I thought I'd give you the first problem to give you ideas on how to attack the second. All right, so we're going to start with here a transfer function. Okay, so a given transfer function that shows up as the plant in our feedback control system. And then what you're going to do is you're going to walk through the root locus for various types of controller designs. Okay, so you're going to look at just a constant gain. Okay, so d1 of s is equal to 1, but then when you do the root locus, you scale that by k. So k times d of s is what ends up showing up in this block. All right, so when you do the root locus as a function of k, it tells you sort of the range of roots of this system or the poles of the system, and that helps shape the response. Okay, so you start with a gain constant equal to 1, then you try a different form of the controller where there's a 0 at -2 and a pole at the origin, and then the third one is we have 2 zeros and a pole. All right, so you go through here and you look at the root locus, and you should take a look at the rules for plotting a root locus, because it gives you intuition about what happens when you add poles and zeros at different locations and how that influences the shape of the root locus. And of course, once you know the shape of the root locus, we've talked about several times in this course how you look at pole locations and you get an idea of the time domain response based on a second order model approximation. Okay, so that's the steps I want you to go through for this first problem. And then the second problem, you have just a slightly different transfer function, but it's not that much different. Okay, so some of the ideas from the first problem should help you solve this second problem. You might recognize this was originally on exam 2. And so you're going to go through here, you're going to plot the step response of the open loop system. You're going to see it has a lot of overshoot. You can determine that from MATLAB. Look at the plot, figure out the overshoot. And then you can hand verify that in the next step. And then I want you to make a root locus argument that no proportional controller with a constant gain can improve the overshoot response. And then finally, propose a design where you can improve the overshoot response. Okay, and what's important is to explain the reasoning behind your choices. Okay, so that's it. That's what I want you to work on. Hopefully these hints will help you.